Hello, this is Mrs. Gregory. This is for my 8th grade class, and this is your video on notes for lesson 38, and it's on page 250 of your book. Today's lesson will be covering using properties of equality to solve equations. This is very much algebra, and I'm hoping that if you get this is a very big step to understanding solving variables. Okay, so let's go ahead and get started. Your book starts with a new concept right here, and I'm going to explain it a little bit because you need to start looking at your equations as a balance, okay? And usually if you see this piece right here, it's kind of our equal sign, all right? And we have part of the equation on one side and part of the equation on the other side. And what we want to do is always keep it balanced, especially if there's an equal in the middle. All right, so we're going to learn about inverse operations, and we'll be using inverse operations to manipulate, the word manipulate our equations, so we can change our equation around, yet we don't change the equation itself. And one of those things we talk about inverse operations, let me go ahead and move my book out the way, are operations that undo each other. We're already familiar with these things. We are already familiar with the fact that addition undoes subtraction and subtraction undoes addition, all right? And then the same here, multiplication and division are also what we call inverse operations because they undo each other, all right? This is not a new concept. It's just we may not have used this word before, inverse operations, and we may not have used the word undo, but we kind of understand this is what's happening here, okay? Now, the main thing that I want you to understand, and this should be in your notes, is this idea, and it's called the operation properties of equality. And an operation usually means, and I'm going to go ahead and write this down here, it's either addition, subtraction, multiplication, or division. All right, those are operations. And we're going to talk about something called the properties of equality. All right, property of equality. And here's what it means. It says whatever you do on one side of an equation, you do the exact same thing. You do the same on the other side. I added the word exact, but it's true. You want to do the exact same thing to another side. All right, so let's go ahead and talk about what that means by go ahead and looking at your example number 1. All right, example number 1, I went ahead and wrote out for you. Let me go ahead and get the correct book. And what we want to do in this equation, it says it's a word problem, all right? And in the word problem, it says, after spending $2.30, Robert had $5.70. How much did he have before he spent $2.30? All right, so let's look at that equation a little bit. Let's read it again. After spending $2.30, Robert had $5.70 left. How much did he have before he spent the $2.30? All right. Now, when I'm looking at this thing, read it through twice, like I always suggest that you do to understand what's happening here, is what we're looking for is how much did he have before he spent $2.30, okay? So I'm going to say this is our mystery. And when we have a mystery, we a lot of times want to give it a variable. So I'm going to say, I'm going to give x. X is a normal variable, which is why we don't use multiplication symbols too much. We use x a lot. But I'm going to say x is the money, the amount of money he started with. I'm just going to say he started with because it's the money he had before he spent it. He started with, okay? And it just so happens that the money he had, he spent $2.30, which means we subtract $2.30. And when we did it, he had left over $5.70. All right, I hope that makes sense. Think about that for a second. Now, a lot of you can have already figured this out without using algebra, but we've got to use our algebra. We're going to learn how to do this Let me find this in the right place. And what I want you to do is think about now, if this is the algebraic way, and you're going to say, Mrs. Gregory, this is a whole lot harder than I would have done in my head. And I'm going to say probably, because it's pretty easy. What I need to do is just add these two, correct? Add 570 and 230. I will have how much he spent. I can do that almost in my head, right? I can just look at that and realize it's going to be about $8. But that's not what we want to do. We're going to learn how to set this up as an algebraic equation, all right? You guys have got to learn how to do that. And then we're going to do what we call, whatever we do on one side of an equation, we have to do the exact same thing to the other. Now, in your example, they went ahead and gave you this part. This was part of the example. But I wanted you to see how you would logically get to this answer, logically come up with this equation, because eventually you're going to have to come up with this yourself. All right. Now, logically, I'm going to say I needed to add the two. Well, algebraically, you would too, because what we want to do is what we want to call isolate. We want to, number one, isolate. Let me write that down. Isolate our variable. Isolate the variable. And I'm going to write the variable right here is the letter, right? So we're going to isolate it, which means I want it on one side by itself of the equal sign. Well, it's not by itself. This $2.30 is here on this one side. So we have a thing where we can manipulate this and say, well, I know that minus $2.30, notice this is minus $2.30. If I go ahead and add $2.30 to this side, do you notice that these are opposite numbers and this will go to 0? But here's where the property of equality comes in. It says if I add $2.30 on one side of the equation, I need to add it to this side also. All right, this is our property. I'm going to put property of equality. All right, we can do that. And I'm going to put a plus sign here because we're adding on both sides. All right, which now this is x minus 0. When I add down, I'm left with an x. This becomes a 0, which I don't need to bring down, but I'll go ahead and say plus 0. It doesn't hurt anything. Equals, and I add it together. This becomes 0. 7 and 3 is 10. And I was right. It's $8. Could have done it in my head. So x is equal to $8. All right. So my answer was he had $8 before he spent the $2.30. All right. It'll take a little bit to get used to this, this idea of thinking things, because a lot of times we're doing this algebra and we're going, my goodness, why do I need an algebra? I just need to add these. Well, that's true. And the truth is that's what we did. We ended up adding them. But you need to know how to work these equations and how to set them up. Okay. Now your book right now is giving you those equations. All right. They're pretty much giving them to you and asking you to solve them using these inverse operations to isolate the variable. All right. So that's what we're learning right now. Okay. So let's go on to example number 2. All right. Let's go on to example number 2. Example number 2 says, if a 12-month subscription to a magazine cost $8.40, what is the average cost per month? All right. And then what they said was 12M equals $8.40, which makes sense because what I'm missing is, I'm going to use X as my missing, is how much is the cost per month? Cost of, I'm going to say each magazine. That's what we don't know. Magazine. I'm just going to give it this. I think your book uses an M, but it doesn't matter because I know that 12 magazines, all right, we don't know how much is equal to $8.40. All right. So this is technically what they gave us. They said 12M. I'm using 12X. All right. Now, I know how much it costs for 12 magazines. And this is technically 12 times X, right? This is 12 times X, all right, equals $8. And I'm just going to take the dollar sign off for right now. So what we can do, the opposite operation of multiplication is division. So if I take this whole thing and I divide it by 12, and remember every fraction, I divide this side by 12, guess what? 12 over 12, right? It becomes a 1. So X is equal, so now we know how much is one magazine. One magazine costs whatever $12.40 is divided by 12, which ends up being 70 cents, right? Per magazine. All right, so I'm going to say here we set up our equation. This is our original equation. And then we use the division or division property of equality. And notice whatever we do on one side, we do the exact same thing to the other. And therefore, then we can find out how much one magazine costs, not 12 of them. It'll take a moment. Some of you've already got it. All right. But if you don't, I'm giving you some extra videos to watch. It will be in your, on your Monday email. And your Monday email has that Khan Academy links that I want you to go to and do those lessons, all right? Because it gives you a little bit more in depth. All right, let's go to example 3. Now, example 3 right here says to solve 2/3 W equals 3/4. Now, again, I want to isolate. It is, in a sense, the term is isolated, but I don't want 2/3 W, I just want 1. And I want you to remember, we've learned this before, remember that if I multiply by its reciprocal, remember if I multiply 2/3, which is the reciprocal, 3/2 times the reciprocal, 2/3, these are reciprocal, I'll end up with 6 over 6. Which is equal to 1. We're going to manipulate this so that we end up with 1W, but whatever we do on one side of the equation, we must do the exact same thing to the other. So here, I'm going to go ahead and multiply this side by 3/2, 2/3 W, and I'm going to have to do the exact same thing and multiply this side by 3/2. All right, both sides. I'm doing the exact same thing to the other side. This is our property of equality. Now, if you'll notice, this becomes a 6 over 6. All right, 6 over 6W is equal to 3 times 3 is 9, 4 times 2 is 8. And notice this goes to 1. 6 over 6 is a 1. So my W is equal to 9 over 8. Or some of you will like 1 and 1/8. Either answer is correct. All right. Now there's times where 9 over 8 is enough. You don't need to do any more. And then there's going to be times where you need it to be 1 and 1/8. All right. If you need to, you might need to rewatch this. But take a moment. All right. If we multiply by the reciprocal, that helps to turn this. We've manipulated that into a one whole. But whatever you do on one side, you have to do to the other, right? Remember, too, this is the other thing, that I'm not trying to, there's a lot of people that are going to say they don't know which one to multiply with the reciprocal. I'm trying to turn the W into a 1W. I need the variable on the variable side. So when you see the coefficient, that's the one that I need the reciprocal of. Okay, there's going to be many of you kind of confused which one. You want the W to eventually be a 1 by itself, because that's what we're looking for. We're solving for W. All right. Example number 4 is using decimals. I hope that this is not a big deal, but we want to find X. All right, that's the variable we want. First thing we want to do, we want to isolate it. Isolate it means I want it on one side by itself. Okay. So this is X minus 2.3. 1.5 equals X minus 2.3. Well, I want X by itself. One thing I can do to get rid of a minus 2.3 is to add 2.3 on this side, and that'll turn that to a 0. That gets rid of it. But whatever you do on one side of an equation or an equal sign, you must do the exact same thing to the other side. So we keep it balanced, okay? This is our balancing act. So if we add 2, 3 to this side, which turns that to a 0, we can bring the X down. X is now equal to 3.8. And that's our final answer. Now, to check it, just put 3.8 up here and subtract 2.3. Make sure it equals 1.5. All right, guys, that's your examples. I'm sending you to go work on your practice set now, which is on page 254. I've also sent you the links to the Khan Academy. So if you feel like you need more instruction, go straight to that and then do your practice set. Your next video that I'm going to be making is your practice set 38. All right, so go have a great day and take time, learn this. All right, bye now.